Alright, so in this problem, longest increasing subsequence, like the last one, very similar, but the only difference is that it's not continuous, which makes it a lot more difficult because the numbers no longer have to be next to each other. They can be anywhere within the array as long as they're going from left to right. So the problem statement here says, given an integer array nums, return the length of the longest strictly increasing subsequence. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. For example, 3, 6, 2, 7 is a subsequence of the array right here. Right? So given an array like this, what would be the answer? Well, we're only returning the length of the longest substring. We're not actually returning the sequence itself, which makes this a little bit easier. And the algorithm to solve this problem is pretty cool because what we're going to do is we're going to have a copy array. Before I get into that, I do want to show you what the answer would look like. So the answer, the longest increasing subsequence of this array would be 2, 5, 7, 101. That could be a possible solution. Has a length of 4. Another possible solution would be like 2, 3, 7, 18. That's another possible solution. But since they both have the same length, it doesn't matter which one you come up with. All right, so the algorithm to do this is pretty cool. So what we're gonna do is we're gonna start at the beginning and just add the first element to our copy array. And what we're going to do is iterate through this entire nums right here, and we're going to drop elements into our copy array here and delete them and delete the ones that we don't need, right? So we're going to check. So okay, we're right here, and what we're going to do is we're going to drop a 9 down in here because that's the next iteration. And then since 9 is less than 10, we're going to delete the 10 and then continue. All right, and then we're going to drop a 2 because that's the next iteration. And then we're going to say, okay, well, 2 is less than 9, so we're going to drop the 9. We don't need it. And then what we're going to do is say, okay, well, this is 5. We're going to drop the 5 down here. And since this is increasing, we're not going to drop the 2. We're going to keep it because that's what we want. We want increasing. And then we're going to keep iterating and then drop a 3 in here. Now it's no longer increasing. So if we want this 5, we can't have this 3. But we rather have a 3 than a 5 because the lower the better. So we're going to drop the 5 and put the 3 there, and then keep going. And then drop the 7, it's increasing, and then drop the 101. Then it's increasing, and then drop the 18. Then once we drop the 18, we realize, okay, wait, this is no longer increasing. It goes from 101 to 118. So we're going to drop the 118 and just have this. And this would be our answer. And the length of this equals 4, which is the answer that we're looking for. All right, I can do this. I'll do this one more time with one more array, just so you really understand what we're doing. All right, copy array. So our copy array is always going to start off with the first element of whatever the array is in nums, and then we're going to keep dropping them off. Right, so we're going to drop a 1. So this is increasing, so we're going to keep it. Then we're going to drop a 0. And this is a good case because if we come across a number that we already contain, so we already contain a 0 in here, so we don't want duplicates in an increasing subsequence, so we're going to completely skip it. So if we already contain a 0, we're not ever going to contain another one. So if we come across a duplicate that we already have in here, we're just going to ignore it. So we're not actually going to add this 0 in here, and we'll just continue. Now we have we're going to drop in a 3. We're still increasing, so we're good. Then we drop in a 2, and now we're no longer increasing. Now what we want to do is we're going to drop this 3 and just keep the 2. And that, because we always want to get rid of the higher number. It's always better to have the lowest possible numbers you can put. And then we're going to add this 3 in here, just like that. And then our longest increasing subsequence would also be 4 for this example too. But if you ever, here I'm going to try to make a test case has a very specific problem in here. So say it was like this 3, and then okay. So say you're given an input like this. This is a very interesting case where we're gonna drop in here and then keep going until we reach this 1. Now, what we want to do is we're not gonna delete the 3. We're gonna delete the 2. Like this, right? So we're gonna loop through this array that we have right here and take this element and put it where it belongs. It doesn't belong right here because if we delete this 3, we're still in a decreasing order because we're going from 0, 2 to 1, and we don't want that, right? We want to have it so that it's in order all the time. So we're gonna place this 1 where we need to in the loop. So we're gonna loop through and say, okay, is nums at this iteration greater than 1? No. Is nums at this iteration greater than 1? Yes. So we're gonna delete and then insert. And that's what we're gonna do throughout the entire thing. And then we're gonna keep going and then insert this 9 and then our answer here would also be 4. So that's the algorithm to solve this. And yeah, let's code it up. So first we need that copy array. So I'm gonna make a vector, if I can spell it right, of integers. And I'm gonna call it current, because it'll just be our current array here. And then we need a set, and the set is gonna contain, I'll call it scene, and it's gonna contain all the numbers that we've seen before. But first I'm gonna initialize it with an initial number of nums of 0, which is the first element within the nums array. And I'm also going to add the first element to the current array. So we never start from a blank array. We always start from the first index. And then we can start looping through nums. So I'm gonna make a pointer and set it equal to 1, because we're gonna start from here and loop throughout the array this way. And we already added the first element, so we don't have to check it. All right, and then I'm gonna say while pointer is less than the nums.size, just to make sure we're in bounds. We're gonna increment the pointer. We'll do that last. And then we're gonna have a condition here that's gonna say if the current at the last position is less than the, I spelled nums wrong, is less than the nums at the pointer. So we're comparing, so if we take back to this example, we inserted the first element 10, and then we're checking, okay, is 10 less than 9? Which it's not. But if it is, say we ever get to, is 2, if we're right here in the array, 2 and 5, is 2 less than 5? All we want to do is insert that 5 next to our 2. So we're just going to put current dot push back that nums at pointer. And we also want to insert it into our set, so we know that we've seen that number before. And then else if the current at the last index, so current at current.size minus 1 is greater than nums at ptr. Now this is where the looping happens. So remember this test case down here where we had to loop through this array and insert it at the appropriate place? That's what we got to do here. So we're gonna loop through our current array. So for int I, 0 if I is less than the current dot size I plus plus, and what we want to do here is say if current at I is greater than nums at PTR, which is the number we're trying to insert, we're going to set current at, well, first we should erase the number from our scenes set, so we've no longer seen it because we're deleting it. So I'm gonna do scene dot erase, I believe is the method, and we're gonna delete we're gonna delete current at I. Yeah, that should work. And then we want to do current at I is equal to nums at PTR. So we're just placing that number in that array. And that should do it. And I believe we also need, oh yeah, okay, so we're erasing it, but we're also adding one. So we should also insert the new number into our set, so we've seen it before. Insert nums at PTR. Okay. All right, and let me just look over because I typed a lot of code here. And then once we do that, we should definitely break out of the loop because we already done the operation. We don't want to keep going. Okay, and then after that, we just increment the pointer, and then we're going to return the current size. Yeah, all right, and then I think my angle brackets are messed up here. Oh no, we're good. All right, so we're just gonna return current.size, and we'll see how this runs. I might have made an error somewhere. All right, accept it. That's good. All right, let's submit it. All right, we have a wrong test case here. All right, let's go over it. What happened here? Okay, so we have 4, 10, 4, 3, 2. Okay, so when we go through this array, what's going to happen is we're going to drop the 4 in, then we're going to drop the 10 in, and now, oh, okay, so the reason why it was wrong because we ran into a duplicate, and I forgot to, so we're building this scene array to make sure that we know what numbers we've already seen within our current array, so we don't have to iterate it twice and we can get it in constant time. But I didn't actually add the condition that makes sure that we don't run into the same number twice. So if scene.find nums at PTR is not in scene.end, then we want to do all of this. So where's my angle brackets? Okay. So this makes sure that, so the problem here was that our output was 4 when it should have been 3, and it was 4 because of this duplicate. And the duplicate, we added it down, and then we deleted the 4. So it looked like this. And then we had 2 4s, and then we drop a 3, and then we delete one of the 4s for the 3, and it was a whole mess. And that 3 would have gotten inserted before the 4, and then we would have kept going to the 7 or 8 and 9, and the array probably would have looked something like this, giving the length being 4 instead of 3. But that should fix it. Let me run it again with that test case on my own. Like that. Okay, yeah, now it works. And we can submit it. All right, perfect. All right, we solved that one. Pretty fast time complexity. The space it does take up a lot of memory because we're making this copy of the array, but we can actually make this algorithm even faster. I'm not going to do it in this video, but if you wanted to make this, because this is, I believe, what is this, quadratic? Yeah, we could make this O of n log n if we implemented a binary search instead of a linear search right here. Because we're iterating through it again, it's making it quadratic, but if we implemented a binary search, which has O of log n time complexity, we can make this O n log n solution. But if this, I'll say if this video gets like 3 likes, I'll implement a binary search to this algorithm.